Hey guys, welcome back to my channel, and in today's video we are going to solve one more LeetCode question, that is question number 404, sum of left leaves node. So this is an easy level question and this has been asked by these companies. Now let's see what this question is all about. So we are given a binary tree and we have to return the sum of all left leaf nodes. And a leaf node is a node with no children. A left leaf is a leaf that is the left child of another children. Now in this question, we can see in this example that we need to return the sum of left leaf nodes, and in this diagram there are two left leaf nodes, that is 9 and 15. So the sum of these two is 24 and that is the output. So it is pretty easy to find out whether a node is a leaf node or not, because we just need to check whether that node is having any children or not. And in that case, if there is no children, then we can say that the node is a leaf node. But the quite challenging part or a bit of difficult part is to distinguish whether that leaf node is a left leaf node or a right leaf node. So let's see how we can come up with a understanding that which node is a left leaf node or right leaf node. So in this example, we know that in order to recognize whether this is a leaf node or not, we simply need to check if a node is having any child or not. That is very clear to us. But the thing is, how we are going to find out that this node is a left leaf node? Because once we are at this node, there is no way back where we can get the information whether this node is a leaf node or right node, correct? So how we can come up with a solution with which we can recognize that this node is a left leaf node? So the first thing or the first approach can be, we will always be searching for left child is leaf node or not. Rather than checking that a node is left child or not, what we are going to do is, we are going to check whether the left child of any tree is a leaf node or not. So as we are suppose at this place, so what we are saying, check whether the left node of this parent is a leaf node or not. Rather than going to 15 and checking that this node is a leaf node or not, what I am saying, being at a parent node, ask whether that the left child is a leaf node or not. So in this manner, we don't have to be worried about whether we are checking left node or right node, because we know that we are already going for left node. We just want to know that this left node is a leaf node or not, correct? So this is the first approach. And second approach can be when we are going to any child node, we can pass a pointer or a flag that this is a left node or a right node. So in this manner, we will be aware that whether we are dealing with a left child or a right child. So these are the two approaches. The first approach, where we are talking about that we will always be checking the left child, is the one which will be more useful in iterative solutions, iterative traversals, and the second one will be helpful in recursive approaches. So these were the two approaches, and for this video we are going to use the first approach, where we will always be checking the left child of any parent, that the left child is a leaf node or not. We will only be checking this part. So let's see how we are going to proceed with this approach. So for this video, we are going to solve this question using iterative traversal, and that even pre-order traversal. Now we can use any order traversal, because at the end we are going to return the sum. So it really doesn't matter which traversal we are taking, or in which manner we are going to traverse the tree, because at the end we have to return the sum. So for this video we are using pre-ordered traversal, and because we are using iterative approach, so let's firstly define our stack and let's name it as node. And in our stack right now we are passing the root, which is 3. So now what I am saying, pop this node and check its left child, whether that left child is a leaf node or not. So what is the left child of 3? So that is 9. So what I am saying, check if this is a leaf node or not. So for that what we will do, we will check if this node is having any child or not. So as we can see, there is no child, there is only this node. So this is a leaf node. So what I am saying, return it and add it up in our sum. So now my sum is 9. Correct? And once I am done with this step, what I am saying, now just push the left and right child of this node in the stack. So now my node stack will become 20 and 9. Now I am saying again pop the node. So now I will pop this node. Is there any left child to it? There is no left child to it. So what I will do, I will proceed and pop the next node from the stack. So that is 20. Now once I am working with this node, 20 node, I am going to do the same thing. That is, firstly I am going to check the left child of it. So I am saying check the left child is a leaf node or not. So we can see this is also a leaf node because there is no children node present here. So what I am going to do, I am again going to add this value in our sum. So this will be 9 plus 15. So it will become 24. Now after I am done with this step, what I am going to do, I am going to again repeat the same thing. That is, I am going to append these child nodes in our stack. So this will become 7 and 15. Again I will do the same thing. I will pop 15. I will check whether there is any left or right child. If not, then I will pop the next node, and again I will check the same thing if there is any left or right child. Because if there is left child, then firstly what we are doing, we are simply checking whether it is a leaf node or not. If it is, then we are adding it up in our sum, and if it is not a leaf node, then we are simply appending it in our node so that we can further process it. Right? It's as simple as that. We are simply appending node, processing their child nodes, checking whether there is any left leaf node or not. If yes, then adding it in our answer, else simply proceeding and processing the further nodes. And that's all for this algorithm. Simple and short. So as we can see at the end of this traversal, we are having a sum equivalent to 24, which is the answer of this question. That is the sum of the left leaf nodes. So this was the iterative approach, and the time complexity of this whole algorithm is big O of n. Correct? Because at the end we are going to traverse the whole tree, all the nodes, where n is the number of node, and after traversing these nodes we are checking whether there is a leaf node or not, or we have to add the value of that node in our sum or not. So for that we are going to traverse the whole tree. So that's why our time complexity is going to be big O of n, and space complexity is also going to be big O of n, because in worst case scenario the stack can go up to n size. Correct? So if the structure of tree is somewhat like this, so in that case the space complexity will also be big O of n. We always consider worst case scenarios when we are talking about space and time complexity. That's why we are taking big O of n for both. So this was the whole explanation. Now let's quickly code this solution, and we are going to code this in two languages, that is Python and Ruby. So let's firstly code it in Python. So let's firstly define an edge case over here, that is if root is none, in that case return 0. And if this is not the case, then let's create our nodes stack, and inside this pass our root. Then there will be another variable named sum total initially, which is 0, because we are going to add the value of the left leaf nodes, correct? So now we are saying while we have our nodes stack, firstly pop the node, that is node equivalent to nodes.pop. After this, check if node dot left is a leaf node. So afterwards we are going to create a function which will be named as leaf node. So if this is true, then what we are going to do? In that case, we are going to append the value in our sum total, that is node.left.val. Once we are done with this step, we are saying check if there is any right node.right child. So if there is any node.right child, then nodes.append node.right. Same thing we are going to do for node.left as well. So nodes.append node.left. This is S, nodes.append. Okay, so after stepping out of this while loop, at the end we will return sum total. Now we need to define this function, right, which is checking leaf node. It is not a mandatory thing that we need to define a function for it, but yeah, it will be nice and clean if we are going to do it in that manner. So we are saying simply check if node is not none and node dot left is none and node dot right is also none. So we are checking three things here. We are saying if node is not none, that means there is a value in node, but the left is none and right is none. In that case, the node is a leaf node, left leaf node, because at the end we are passing the left node only in this function, because we only want to check the left node, correct? So now let's run this and check. Okay, let's submit this. Okay, so this has been accepted. Now let's quickly code the Ruby solution as well. So in Ruby as well, we will do the same thing. Firstly, we will check that edge case where we need to return 0. So if root is nil, then return 0. If not, then create our nodes stack, inside which pass the root. Then there will be a variable for sum total, which is 0 right now. Then run a loop until our nodes dot empty is true. And inside this, what we were doing, firstly we need to pop the node, right? So nodes dot pop. And then we need to check if leaf node, and inside this what we need to pass, node dot left. So if this is true, then update our sum total with node dot left dot val. So this is the first thing. Then we are saying if node dot right is there, then append it in our stack. Same thing we are going to do for left node, node dot left, if node dot left. And after stepping out of this loop, return sum total. And now we need to define that leaf node function. So here we can define our leaf node function, inside which we will be passing node, and inside this we are saying check if node is not null. So for not null we need to add this sign. With this check, node dot left is null and node dot right is also null, and if this is true then we are saying it is a leaf node, left leaf node. So this is also submitted. So this was the whole solution with explanation, and I hope this video was helpful for you all, and if it was, then don't forget to like, share and subscribe my channel. I will soon come up with more such questions. Till then, keep messing with algorithms, and thanks for watching.